Hi, and welcome to the evolution of Agile. Today we're going to be talking about spiraling away from waterfall, a total quality revolution. So we're going to start with total quality management because the heart of Agile today really is in TQM. And of course, TQM was developed by Edward Deming. He's the father of TQM. He developed it for Japan and then brought it here to the US. And in the end, we still follow his principles today as we continue to evolve our approaches. What he said was that improving quality actually decreased costs. Decreasing costs is something that was a huge emphasis in the 1950s with the management revolution of the time. But what a lot of people thought was that quality was in competition with cost. What Deming proved was that it wasn't. He said that every system must be in a state of continuous improvement in order to succeed, and that an organization could survive based upon the pride of the work that was being done by its people. That a knowledge worker was especially different from other types of workers because they knew more than their boss did about the work they were doing. And he, of course, emphasized what has become infamous today as the PDCA cycle, or Plan, Do, Check, Act. So when we think about Plan, Do, Check, Act, this is an approach of continuous improvement. It's something that is applied in Lean, it's applied in Agile, and it's a great approach to understanding something, a system, that you can't necessarily easily model from the outside. You have to test it. And the proof that he actually was successful with his approaches was back in the 1980s, where he actually turned around Ford. Ford was losing money hand over fist. And in 1986, he actually took them from $1 billion of losses to their first profits in years. And they've been a great company ever since. Now let's talk about the Toyota production system. The Toyota production system is actually an evolution of TQM, which started in Japan. And it was designed and architected by Taiichi Ohno. And of course, he learned a lot of the techniques by observing systems both in Japan and here in the US and identifying areas to eliminate waste. And so the waste that Taiichi Ohno really focused on were 7 types of waste. He talked about movement, the movement of materials between 2 locations. He talked about inventory, the buildup of inventory, which costs money for having to store it and stack it. The motion that it takes to actually complete a task and wanting to limit that so that you can be as efficient as possible. The waiting on work, the waiting for work to be done from an upstream process to a downstream process was a huge source of issue and a huge source of waste. Followed by overproduction, producing too much of a thing, overprocessing, working on something too much, and then creating defects, which of course would have to be fixed later. So in order to identify where these wastes existed, he used a system that we call Kanban. And Kanban actually just means billboard in Japanese. And the way that it works is that you simply use a board in order to identify when a process needs more material or needs more work. It's a pull system for getting work done. And so the simplest form is to have a to-do column, a doing column, and a done column. So when work is no longer existing in the doing column, you can pull from the to-do column. And once work is done in the doing column, it moves over to done. This allows for a system to know when something upstream or downstream is ready for work. And then finally, continuous improvement and testing was a key part of the Lean movement. It involved developing key performance indicators, which were a time-bound performance metric. So if you ever use KPIs in your workplace, you can thank Taiichi Ohno for that. Proof that this works is the fact that Toyota was actually and has been a top 3 manufacturer for years, ever since the introduction of the Toyota production system. And their employee satisfaction rating is 70%, which is more than double what we see here in the US today. So not just being a top 3 manufacturer, but also having really happy employees was great outcomes from this system. Then let's talk about the theory of constraints. This is the last of the Lean movements that had a great impact on Agile today. This is a system that was developed by Eli Goldratt, who is the father of the theory of constraints. And of course, his famous book that almost every MBA has to read is The Goal, where they talk about how a system is going to be managed usually by just one process, or if it's on a team, just one person on a team. And that person or that one process becomes a bottleneck. So when we think about bottlenecks, the way that that works is kind of like the diagram you see up here, where you have one process, in this case process C, is going slower than all the other processes in the system. As a result, material is being built up behind process C. And so whenever you see a system like this, you need to address it using the 5 focusing steps of continuous ongoing improvement. So the process of continuous ongoing improvement starts with, first, you got to identify the constraint. Then you exploit it. And the way you exploit it is that you identify the best way to raise it you can without making any changes to the system itself. Then you subordinate all other processes. You only run A and B when C needs more material. Finally, 4, you try to eliminate the constraint, which means improving the speed of C. And then 5, you prevent inertia from becoming the constraint, which is you don't want to stop there because eventually the bottleneck will move. There will always be a part of your system that is the slowest moving. Proof that this works is actually, this was a system that was used intently with the cleanup of the BP oil spill. And as a result of implementing TOC, they believed that they were able to save over $200 million. It's quite a lot of money. And they used this in order to orchestrate and plan and deploy over 10,000 boats cleaning up the Gulf of Mexico. Now let's talk about the waterfall mistake. The waterfall mistake is a history of having misinterpreted a model from the 1976 paper by Royce, which identifies a way of producing IT systems. And what it says is that all work can be modeled as being linear, where you start with requirements and then you go to design, then implementation, testing, and maintenance. However, the issue with this approach is that there's no opportunity to go back. As a result, by the 1980s, we saw that waterfall was a predominant model. It had been picked up by the DoD, and it resulted in what we call today the 90-90 rule, according to Tom Cargill from Bell Labs. And the 90-90 rule said that the first 90% of development accounts for the first 90% of time, and the last 10% of coding development accounts for the other 90% of development time. Essentially, every project was taking at least 1.8x times the original development time estimate. What we saw was that only 10% of projects during the 1970s and 80s were actually succeeding in meeting their goals. And this is because of the fact that the waterfall model was never intended, even in its original design, to be used this way. In fact, if you take a look at what Royce proposes being the correct method, it looks a lot more like an iterative approach. Much more complicated, but if you look to the right side of this diagram, you'll actually see that it shows a feedback loop from testing to development to requirements, just like what we talked about with Lean. So perhaps the most costly mistake in the world was the adoption of the waterfall approach. It continues to reverberate today, but you're here learning Agile, so you'll be able to do it better. Now let's talk about spiraling to Scrum. Spiraling to Scrum starts with RAD. RAD is the Rapid Application Development approach that was popular in the 1970s to 1980s. Here, as an alternative to the waterfall approach, RAD believed that you could start with upfront requirements, but then you would have to iterate in terms of the design and testing it with users. And as this iterative approach would go on, you'd finally find a workable solution and then cut over. So it was a basic alternative, slightly iterative, like what we were learning from in Lean. Then with dynamic system design models, or design method, this approach was developed in the 1980s. It became very popular because it didn't just believe that you should iterate on design and development, that you should also iterate on requirements. And so it had a feedback loop for requirements as well. But then finally, all this iterative approaches coalesced into extreme programming. And so extreme programming actually believed that you should have feedback loops at every level, be it from pair programming to unit testing to stand-up meetings, acceptance testing, etc., all the way up to the release. By having this continuous feedback loop, you could learn if what you were doing was right using a test-driven approach. So the key tenets here was that at first there was consolidated upfront planning, and that eventually went away in terms of XP moving into more of an iterative approach. The approach would always be iterative in design and development. There was a use of time boxes in order to get these feedback loops. They used actually user stories in XP because they wanted people to explain in terms of a business requirement. And then finally, test-driven development to get that learning and development. if we look at the results today in terms of what we're achieving with Agile, according to a 2013 cross-industry study, we see that Agile is not just more successful, but extremely more successful by 15% more. Traditional is still failing half the time, but in Agile you see a success rate of 64% or better. In terms of challenge projects, Traditional has about a third of their projects are challenged. With Agile, it's less. And then finally, with Traditional, you see a much higher failure rate. In fact, over 2 times as many projects are failing. So these approaches were very successful at addressing a lot of the issues, but we're continuing to get better in terms of what Agile can do. I hope that this evolution of Agile was useful for you, and that now that you understand the history, you can explain a little better to others when they ask you, where does this all come from? Hope that you're enjoying the course so far. I look forward to seeing you next time.